Friday Night at Carey. I'm Bill Schlesinger, president of the Carey Institute. Welcome back to our fall series of Friday night speakers here. And tonight we have a very special speaker, a noted biologist and author, David Haskell, with us. He heralds from degrees at Oxford and Cornell. David Cornelli and myself, I give special credit for that connection. And now makes his home at the University of the South, Swanee, for his home. And his new book, The Forest Unseen, looks like that, Haskell asks us to look at the little things in nature, and he has made studies of looking at a square meter of forest floor for a long period of time to see what is happening down there in the decomposing leaves and all the little critters that live in those decomposing leaves and cause the nutrient cycle of the forest to function so efficiently. So it's a look at things we might overlook as we go through a forest on a Saturday afternoon. All of that, of course, is essential to the sustainability of forests and forest ecosystems. And David is a real advocate of sustainability and lives on a micro farm, I think is what you call it, in Tennessee, trying to live with minimum impact on the landscape. The Forest Unseen has had great acclaim. Just this morning I got an email coming across my screen that said that the National Academy of Sciences, the highest body of science in this country, had awarded it the annual recognition for science communication, the Best Book Award. And so that just came in today. And earlier in the year, the Southern Environmental Law Center awarded it the 2013 Reed Award for nature writing featuring southern landscapes. As with many of our programs, the book will be available, arranged by Merritt Bookstore outside after the program, and David will be there to sign your copy, should you desire to pick one up, which I highly recommend. We're very pleased to have this cooperation with Merritt, and we have several other authors and book signings signed up as the year unfolds. So without further ado, David Haskell, thanks for being here.
Thank you, Bill, for that wonderful, kind introduction. You will note that my accent is not from Tennessee. I've actually come from the far, far east coast of the U.S. I was born in London and have moved around since then. For the last nearly 20 years now, I've lived in Tennessee, so you may detect a little bit of that as we go on here. It is a delight and an honor to join you here this evening at the Carey Institute. So much amazing science has happened right here on these grounds, and also this connection of science out to the public arena through education and connecting with policymakers. That it really is an honor for me to visit here and share some of my writing and some of my thoughts with you. I'd like to thank Lori Quillen and Pam Freeman in particular for making my visit here such a pleasure and for smoothing out the logistics and so forth. So thank you for that. And to David Strayer, who took me on a little walk. I don't know if David is here this evening, but took me on a walk, and we had a wonderful lunchtime conversation. So I got to see a little bit of upstate New York. And having spent several years in upstate, it is a pleasure to be back at the most beautiful time of the year, right? The humidity has dropped. The apples are going to be coming in. It's not winter yet. So I will discuss my book, The Forest Unseen, which examines some stories of ecology and evolution through the perspective of 1 square meter of forest in southeast Tennessee. This forest is very close to my house. I get on my bike and ride down the road for 10 minutes or so, and then wander out into the woods. I will discuss, I'll do some short readings, try to put those readings into context and explain why I took on this project. I've got other things to be getting on with my job, rather than sitting in the woods for hundreds of hours each year. and also what I took away from the experience at a personal level as well as at a scientific and science communication level. So first, how did I, let me change the PowerPoint and give you some images. How did I pick my square meter? Process of selection here is important. So this is the Cumberland Plateau, looking out over the edge toward Nashville, and Huntsville are out that way, so we're looking west, slightly west and south here. Where at the top is a sandstone cap. You go down through some sandstone in these coves, and then you hit limestone at the bottom, and then you can see a little bit of agricultural land there over on the right, some rich agricultural land in the Highland Rim. This is Shake Rag Hollow, parts of which are old growth as far as we can tell. It got its name, Shake Rag, from the moonshine days, and you wanted your liquor. You go stand on the top of the bluff here on a particular rock and shake your rag. Wow. To get the attention of the moonshiners further down in the valley. You'd leave your money on a rock, come back later in the day, and your money would be gone, but there would be some liquid coin in a jar waiting for you. And many of these mountain coves have got old remains of still all over. There's still a little bit of moonshine perhaps in these regions, but that the illegal economy has moved on first to marijuana growing in the woods, now to meth labs. So, the meth labs are obviously a lot more destructive to both the environment, that's the environmental disaster zones after they being burnt down and busted, but also, of course, to the people who get hooked on that. So that gives you an indication about the economy in this region. For Southern Appalachian economy and interactions with the forest have been a part of the culture there for many generations and generations. So some of my neighbors grew up being treated with medicines from the woods. They then went to the doctor. Grandma, granddad knew which herb to go dig. And so there's this real cultural connection that's still quite strong. Those connections are being broken and frayed now as time goes on. But that's a part of the atmosphere of this place as I can walk out of these woods and talk to people, scientists of course, but also people who have wisdom and information that came transmitted through other means than replicated experiments. So I walked across this mountainside haphazardly until I found a rock that looked like I could sit on it with a reasonable degree of comfort for a year. The 1 square meter in front of that, and that's an area about this big, about the size of a small dining room table. That became my area of observation for the year. So there was an openness to serendipity and a letting go of the agenda right from the get-go in how I picked the square meter. The more scientific way would be to make an Excel spreadsheet or some other program and have like 15 factors that we rank the square meters by, being minimally, and then you run a little sort of simulation, maybe do a little Markov modeling here, and sort of pick the best one, and not just the best one, but the best one from among multiple options. So that's all very exciting stuff, but that's not how I did it. I wanted, the personal motivation was, I wanted to let go of the agenda, to go into the woods and shut up for a change. So as a teacher, my job is, I teach many courses a year. I go into the woods a lot with students, and there's a lesson plan, as there should be. Today we're going to talk about carbon, or we're going to discuss natural selection, whatever it is that's fitting in the arc of the syllabus. That's fine, it's a great way of teaching, but it's quite garrulous. There's an absence of openness in that way of being that I was missing. Same thing with my research. I'm studying this hypothesis. I got this grant. That focuses in the question, and that's a very important and useful, powerful way of engaging with the world. But also, it's bringing the question to the world in a way that I wanted to step back from. So I wanted to sit watch, leave the gadgetry behind, so no cameras, no recording devices. I had a notebook, pencil, a hand lens, and binoculars to allow myself some polished optics. To get a little close, to get beyond those visual barriers and to bring distant things in. So I used the binoculars within the square meter. They were close focus. I wanted to see what that bee was doing on the far away, on the other side of the square meter. You can focus in and you're 10 times closer to these things. So my rules were to leave behind the technology, not because the technology is bad. I love making sound recordings. I love photography. In my research, I do DNA sequencing and all those kind of biological fun things. Here, I wanted the challenge of what can you tell from the senses, and just you and the world. Now, of course, you can't leave it all behind. We bring our sensory filters, and I'll talk more about those in a little bit here. We bring preconceptions, emotional commitments, intellectual biases to whatever we do. As far as possible, I want to step to the side of some of those. So what I'm doing here, of course, is borrowing from contemplative practice. So the idea of sitting in meditation has its place in many religious traditions. This is not a religious project or motivated by any one tradition, but the contemplative gambit is by narrowing your field of focus, you can perhaps paradoxically see further or see in a different way. It's a little bit like a pinhole camera. Those of you who remember this from physics lab, you hold up a sheet of paper or an opaque cloth sheet and make a tiny little pinprick in it. The light coming from this side focuses and forms a very clear image on the back side. It only works if it's a pinprick. As you enlarge that circle, that opening, the light doesn't focus, it doesn't work. So I'm taking the contemplative gambit, the challenge of contemplative practice, to see the world in a grain of sand, as the poets have said. Well, what can I gain from that for myself, and also as food for storytelling when I return from the forest and try to communicate some of these stories to other people. So there are two parts here. One is what I did in the woods myself. I could have done that without sitting down and writing a book. The second part was afterwards I would go to the library, and often I would know that bee was doing this, but who's written something interesting about that particular interaction in the last 20 years? So getting a little deeper into the science and pulling out some of those stories from the literature that, as a biologist, as a teacher, I have the unbelievable privilege of having the top of my head blown off every week or two, some amazing new paper in the Proceedings of the National Academy or on science or a scientific conference. That wonder and amazement is literally unseen, hidden, unknown beyond the academy. To me, that's a tragedy. So partly because we want folks to understand science, and partly it's an aesthetic thing. These stories allow us to see so many more layers into the world, so many more interactions, that our personal experience of walking through the woods or just thinking about a leaf, a forest, a river, what's happening with the clouds flowing over. We know some of the scientific background of that. Our experience is magnified and enriched in many, many ways. And so the loss of the failures of scientific communication are a loss at many levels, and I think a particularly important loss is the level of loss of beauty in each of our lives. My own life has been enriched amazingly by these stories, and I wanted to share that as much as I could through this particular meditation on the square meter. So let me give you some visuals to set this up, and then I'll share some readings from the book and get a little bit more specific. So this is looking down on the forest. In the autumn here, we don't have, on the high ridges, there's some Virginia and shortleaf pine, but mostly it's citrus trees. You get a sense from all the different colors and textures here. Each one of those is a different species of tree. Not, I mean, that's a little bit of exaggeration, but you can see the species diversity of trees. Classic southern Appalachian mixed forests. Every other tree you bump into is a different one, and tree and shrub identification is a lifelong learning process. Down at ground level, there's some patches of wallbows and some big trees. Also very rich understory, the deer haven't completely cleared out. A lot of the understory vegetation. Also a lot of maple coming up in the understory, just like many other places in the eastern United States. Maples, in this case it's sugar maple in the coves, gradually transitioning to be more dominant component of the forest community. North-facing ridge slopes, so lots of spring wildflowers. People come to this particular mountainside from all around to experience the profusion of them. In my square meter, there were well over 250, 300 individual flowers in April. And many of those are spring beauty, which grows in great abundance. But the number of these little flowers is phenomenal, and of course there are all kinds of interesting ecological stories that go with these flowers. They're called spring ephemerals because the flowers don't last long, but of course they're not ephemeral, they're persisting. These are not annuals, they're persisting with below ground storage organs that may be as old as the trees above, maybe older. In fact, we don't really know because there is no, to my knowledge, and I'd be happy to correct it on this, there is no good way because of their growth form to track them right back to how old this is from the seed to the present time. So some of these are common, of course, in the northeast as well. This is bloodroot. This next photo is an interesting reminder of the very fascinating ecological interaction here. These are bloodroot seeds and fruits. They're little slimy, slime is not the right word. This is nice macro photos, so these are beautiful liquid gel crystals, botanical amazement. So the slimy little blobs on these things. What are these for? I'm sure there are multiple people in here who know this. Pollination is already happening. Who is being bribed here? Yeah, ants. To grab hold of these things, what the ants do, that's ant food, just like a cherry is designed to bribe a bird to swallow up the cherry, and then the bird carries the cherry, and that's why you can poops it out, which is why you have cherry trees growing up around fence posts. So, in fact, studies of June ecosystems, a colleague of mine studies dunes. It's really hard to do exclusion experiments in dunes because you put a fence up around a piece of dune, the birds sit on it, they poop out all the seeds, you have a forest coming up, and you don't know what's happening, who's bringing the seeds in. So this is on a smaller scale. This is true, the number of spreading wildflowers, they bribe the ants. So the ant will pick up this fruit in its jaws, take it back to its nest, eat this fatty, protein-rich little snack bar stuck on the side here, and then it's left with the trash, which is the seed. So the ants, being fastidious little creatures, carry that seed and plant it in their compost heap in their nest, which is a perfect place for this bloodroot to germinate. So the ants are the creatures that are really doing a lot of the small-scale dispersal of flowering, the smaller spring ephemeral plants. In the south, of course, fire ants have moved in, an invasive species. They're not nearly so helpful. They tend to eat this elizome, this fatty hive, and then just leave the seed lying there. And if they do carry it off, they don't take it very far. The other little twist here is that some of these plants are up here in the northeast. And what was here in the northeast like 10, 12,000 years ago, a huge pot of ice. And the ants don't carry far enough of those seeds to make it up a long distance. So we got a little bit of a problem. We know there were no bloodroots and hepaticas up in Vermont and upstate New York 10,000 years ago, but they're up here now, kind of a neck here. And it turns out here may be the long-distance transport mechanism. So this is not a good fate for a plant to get eaten by deer. Most of these seeds, if they get eaten by deer, won't survive. They're ground up and won't get put in the right place. But for a few lucky ones that make it through and germinate, they're the ones that do the long-distance colonizing. So on a small scale, if you look this through, you want an ant to take it. But from the species level, which is not the level natural selection goes on, but the species level, the movement of these plants across the landscape is highly influenced by very rare long-distance dispersal events. And you think about human history, same thing. Right? There weren't tons of people coming over from Europe and Africa to the New World. There were few. Some chose to, some brought against their will. And yet, the history of this continent, in terms of human colonization and therefore the history of ecology of the place, is highly influenced by a small number of long-distance dispersal events. So this is a phenomenon that occurs over and over again both in human history and also in the longer time in biology. So some other creatures that we have in great abundance are snails. These are the great unsung heroes of zoological diversity. In our county in Tennessee, we have half a dozen species that are found in no other county in the world, as far as we know. And they are the great connectors of the mysterious dark world of the soil to the sky. So when parent birds breed, the mother needs to make eggs. She doesn't have enough calcium in her body to make all those eggs. If she lives in a calcium-poor environment like sandstone, she needs calcium supplementation. And she can either go to CVS, a few song sparrows, house sparrows have figured out how to do that one. But mostly, no, you're going to look for millipedes or in particular snails. So the snail gathers up calcium from all the algae and fungi it's been grazing on and assembles it in a conveniently coiled package on its back that moves that calcium on and off through the system. They're also come in a variety of amazing forms collected. So these are just a few from around close by the square meter of the mountainside around there. Some of these are quite big. The one in the top left is about a little bigger than a quarter. The one in the bottom right is a tiny little, about the size, a quarter of the size of a pea. So there are dozens of species of landscape. And you get down on your belly with a hand lens, and the world looks like some sort of David Haskell Serengeti special. You've got the herds of the little snails moving. This is early in the morning before the sun's rays cause them to run back under the blue not run, but slide. And then you got the big ones that are grazing around on the crazy big mountain slopes. And an exciting thing about this is that almost nothing is known about the ecology of these creatures. Many of them were described in the late 1800s, and then that's it. So anything you can find out and get onto paper is a new contribution to understanding the natural history and ecology of these species. And because they're sort of tightly tied into the biology of the soil, they make a great zoological lens into those processes. And as a teacher, I'm working with projects that undergraduates can get involved in and make a good, solid scientific contribution without having to have a PhD in some technical aspects of biology. And these as being good entryway drugs into the heavy science of biology. Salamanders, of course, in Southern Appalachians is famous for its salamander diversity. Just a few here, red salamander, desert mavis. These ones are in streams and on the edge of streams are about that big, chunky things, like a newt that has really been using steroids. And I'm familiar to many of you here, I'm sure, on this slimy salamander. It's a species that is now known to be a dozen or more species. Look at the genes of slimy salamanders, and it's clear there are multiple cryptic species all over one of these in North America. And then Also some healthy populations of copperheads, and then this is a rattlesnake that I found just a few weeks ago. Can you see it where it is here? Some can see it, some can't. So your task is to walk across this. You probably don't want to put your foot right here. So this rattlesnake was actually caught up and had just eaten a chipmunk, I think. Very happy, just hanging out, basking. That's a big ash tree that was fallen, just fell this year. I'm planning to follow this ash tree in years to come. But I was sitting on the ash making notes about moss and so forth. And after half an hour, 45 minutes, I realized there'd be a rattlesnake the whole time. And rattlesnakes are not aggressive at all. I mean, if you step on it, I have something to say. But this is an indication that, as you know, in the Northeast, rattlesnakes used to be very common, but because of a number of factors, persecution, development, rattlesnake populations have plummeted to either zero or very close to zero. This is one place where, for the moment, there are still numerous snakes. So some of those ecological connections, like rattlesnakes taking out a lot of small mammals, still happen. Now, there are diseases coming in and so forth affecting rattlesnakes around the country, so it remains to be seen whether this is a long-term persistence. But being here at the Carey Institute, you all know what the role of small mammals is in the ecology of the forest, and particularly the ecology of Homo sapiens, that likes to tramp through the forest and suck ticks upon our juicy, thin skin, out of place, African, not really adapted to North America, genomes. So rattlesnakes are, I'm not presenting data on this, but they are part of that equation in this forest. Other things that were there until very recently are gone. Mountain lions, of course. There are a few bobcats still around in some of these woods. And of course, the megafauna from the Pleistocene, the giant ground sloths, bears, the woodland mice, and all the creatures that were in these forests until just 10, 12,000 years ago are all gone. So our forest is, you can still hear the echoes of some of these species, but most of those echoes are just silent. And you go to a cave just around the corner here, and find the hide of some of these ancient creatures like that ground sloth, bits of skin and teeth and so forth. If the skin is still there, it's such a reminder of how close in time we are to those major extinctions. So we think we're studying the ecology of these forests, we're studying the ecology of the forest that is radically changed with the removal of many of the processes and factors that govern this dynamics for many years. Passenger pigeon, because of the other. So what I did was take some ideas from Buddhism. This is a Tibetan mandala constructed by monks who drizzle colored sand from funnels over many days. And some of you may have seen this process. And so a lot of Tibetan monks go on the road, and part of the way they make their livelihood is constructing these mandalas for cultural centers and so forth. Incredible intricacy, design. My idea was to look at this approach, a lot of attention to one small area, and apply it to an ecological mandala. And I call this 1 square meter forest mandala to connect directly to this practice, this meditative practice from Buddhism. And apply it to something like this. So this is a rock and shake dragon. And you can see that, so that maybe 1 foot by 1 foot on this photo frame. The number of species of lichen and of moss on here. And just a quick visual inspection. Just probably a dozen on that. So what happens when you slow down and actually pay attention to what is right in front of our faces? So let me share some specific messages and thoughts from that. And maybe if we could have the lights up just a little bit. first thing I learned is how often I go through life with my senses just turned off. Like how many times today have I actually attended to my sense of smell? And actually really paid attention to what that food smelled like, or what did it smell like as I moved from the outside of the building to the inside. And what does that tell me about my reaction to this place and what the stories are in this place? Mostly, all of that is turned off. So part of what I am trying to do here is turn on the apps that I came pre-downloaded with. That's the language I use with my students. Put away the phone and turn on your own apps. You came with these amazing senses, so let's use them and see where that takes us. Attend to the soundscape and understand why the soundscape is the way it is now and how it differs from how it will be later in the evening, or how it might differ if there were no cars within 50 miles of here, or if there were a lot more cars, how would things, communication patterns among organisms change, how would the song of trees change? One of my projects now is to attend to what sounds coming from within trees and also coming from the outside and reverberating within trees. So if any of you are tree listeners or have good tree acoustics stories, I would like to hear them. Because I'm piecing together all the different stories and approaches to that question. So, attending to the senses, where does that take us? Well, clearly that's a richer way to live. What does it teach us, though, about ecology, evolution, and science communication? Let me share a reading here that will illustrate, I hope, some of these ideas, or at least one approach to this. So the idea is we are waking the senses and then seeing where it carries us as we riff on science. And this, I tried to pick a reading here that was relevant. This is a little bit jumping the gun because this is from November, but in upstate New York, you'll be getting Tennessee November here in early October. So, which is one of the things I miss about New York is we don't get it. So November 5th, what I'm doing is observing a slug, just hanging with a phytomycid slug, which is one of the native or mushroom slug we have, watching it move through the moist air. And then I start to listen and then to see. My focus on the slug is interrupted by the sound of heavy rain against the tree canopy. Distractedly, I pull on my rain jacket, keeping my eye on it. But I was fooled. There is no rain, just pelting falls of wind-thrown leaves. The squall of leaves settles, adding another stratum to the thickening bed over the mandala. Most of this bed was deposited in the last couple of days. The leaves' tenacious hold on the twigs broken by the extra weight of moisture from the rain. 2 days ago, the forest canopy was thickly met with bronze and gold, hickory and maple leaves. Today, a few sparse scraps pulled out, but the canopy's armor is gone. Finally, rain comes, starting with big, cold, splatting drops and settling into an even shower. More leaves descend. A tree frog rasps loudly from an oak trunk, greeting the rain with full bursts of song. Crickets also. I huddle in my rain jacket, feeling an unexpected sense of aesthetic relief at the changing forest. This is hardly reasonable. Autumn rains presage the cold and the pinching in of life to winter. But some quality that was missing from summer has returned. As I gaze through the rain, I realize that I'm buoyed by an expanded quality of light under the open forest canopy. My view of the forest seems deeper and fuller. I'm released from the narrowness of luminosity that I hadn't known existed. Summer light is constrained, clipped back into a narrow range. In the deep forest shade, yellow-green light rains. Blues, reds, purples are all muted, as are the hues that form in combination with these missing colors. Light under the sun, a canopy is played under a miserly range of stage lights. So what happened in the fall, the sense of opening, partly if there's more light. The forest floor is darker on the summer solstice than it is in the winter solstice, because there are so many layers of leaves stealing those photons. So the quantity of light goes up, the intensity, but more importantly, it opens up. Previously, we were in Monet's lily pad, like yellows and greens, and that's it. Monet has probably paintings as well. But in the fall, we can take our eye off that particular painting and just run around the National Gallery, enjoying all the other colors of the present. So that's an increased sense of sensory enjoyment for us. But the animals and plants that live in the forest responding to it too. The fact that genes have within them the knowledge that these changes in the light are going to be coming down the pipe. So, for example, the proportion of red to far red light within forest gaps determines how plants grow. So if a plant gets a lot of red light, it knows I'm getting a lot of good sunlight here. I'm in the forest gap, I can grow in a bushy form and grab that sun gap for myself. If it's growing in a place without much red light, because it's been stripped out, it grows like a long gangly plant, because it's trying to get up through the forest canopy. And it knows it needs to get up or it's not going to make it. So the whole architecture of leaves on a plant is one big eye, detecting this ratio of red light to far red light. And that determines whether it grows all kind of bushy and compact or whether it grows in a gangly way. As I sat there in the forest observing slugs and so forth, I noticed that the forest herbs, there are a few sweet cicely and some other plants that linger through the summer. Right before the forest canopy comes down, they started growing again. So they're getting a little burst of photosynthesis. And again, in the fall, they can't do that in the summertime that much because all the good photosynthetic light is being stolen by about 4 layers of leaves up above them in the trees. In the fall, it's opening up, and it's not yet frozen solid for winter. There's that window of opportunity. If you put in a little growth, deploy some more leaves, you can get that extra last little boost of photosynthesis in for the rest of the winter, the full rest of the winter. Woodpeckers also use this trick of the light. So when a woodpecker wants to be inconspicuous, it stays in the shade. Its red crest stays out of direct sunlight, and they're pretty hard to see when they want to defend their territory. They jump into a sunflex, or a shaft of light coming down through the forest canopy. And when that gets on their red crest, that red blazes out like a torch held out in the dust of the forest there, because there's hardly any other red happening anywhere else in the forest there. So animals modify their behavior based on the variations of the light environment. If I'm a woodpecker and want to hide, in the shade, my red gets turned off, even though the feathers are still red. There's no red light trims like that. I want to advertise, boom, in the sunfleck, I get some of those red photons, and you see me. Woodpecker pay attention here, but the neighboring woodpeckers see the woodpecker, and the territorial jostling continues. Right now, I just took a walk this afternoon and this evening and saw some red fruits out in the woods around the Institute here. Here are some examples that I put as I took back to Tennessee. This is berry bells, a red fruit, here coming out in the fall. This one and this one. Balsam and seal, or Solomon's plume. And then this, you got some of this here, Jack and pulpit, and then these, spice bush here, it's hard to tell how to do it. So these red fruits are being deployed in the fall. They're having a little bit of a hard time signaling. You can see this one's in full sun, it's quite bright. These ones are in yellow and white, and the red doesn't really pop out quite as much here. Who are they hoping to drive here? Yeah, birds. So there is an enormous wave of particular thrushes, all those great cheek thrush, Swainson's thrush, wood thrush, hermit thrush, coming down from Vermont, Quebec, through sea dispersal. So, and birds, because of the particularity of their eyes, are very sensitive to red, and there's not a lot of other red things in the forest, and so the plants are tuning into this. I don't know anyone who studied this, but my prediction would be the detectability of these fruits goes way up as the fall moves on. Right now it's yellow-green in the forest. Red doesn't pop out. In a little bit, when the red photons come through, these red fruits are really going to send out a strong signal. So my observation of changed light quality in the forest actually connects very deeply into the signaling patterns between animals, plants, and among animals. But it also connects into our own natural history. So red vision is a pretty recent acquisition for mammals. So most mammals don't see red, like dog does not see red. It's just within the primate lineage, there was the evolution of a re-evolution, if you like, of a red color receptor. Perhaps because of fruit foraging in our history. And so we are not unique, but quite special among mammals in actually being able to see red, except some of us can't. Right? So 2 to 8% of men cannot have so-called red-green blood. Colorblind don't have the ability to pull out those red colors as well. And it's much higher frequency among men because it's associated with the X chromosome and so forth. Now, for years that was treated, well, that's an unfortunate mutation, sort of an accident, genetic accident. Now, that story is a little more complicated. Any feature found within a species that is up near 10%, you've got to question whether there might not be some kind of functional significance for that. And if we have a comparative approach and look at other primates, it turns out that other primates, particularly New World primates, have a mixture of primates that can see the 3 primary colors, trichromats, which is what we regard as normal color vision, and dichromats that are so-called red-green colorblind. It's 50-50 in some of these species. But they did some experiments and found that a small group of primates that has that mix does better at feeding. In bright light, because they've got trichromats, they can see all the red fruit and can go and pick out all that. In low light, though, the dichromats have an advantage in that they can see through cryptic patterns and not get distracted by the red and find food better. Now, in humans, we don't know if there's an adaptive advantage there, but certainly in terms of the natural history of primates, the ability to see red or not see it plays out in complicated and difficult ways. And in fact, the military figured this out back in the Second World War, when people were trying to break camouflage codes, sort of fly over areas and find where are the hidden installations. They get colorblind guys to look at those photos while riding on those planes. Because, and this has been shown experimentally, much better at breaking camouflage. Not fooled and distracted by the color, you can actually see and detect texture a lot better. And so, high probability that several people in here have that feature, you should feel good about being able to go out now and break camouflage. And maybe the NSA has their job for you. Maybe changing their color. So, this happens over and over again through the book. A natural history observation. sense of changing aesthetics, some kind of sensory input, that is a window for a writer into other questions. Who are these other species? What are their stories? And then this forest is a mirror into our own ecology, because we too are also animals and influenced by cosmetics, just like other creatures are. I'll share briefly one other example of tuning into the sensory world and where that takes us. Many of you have had this experience, I would imagine, and particularly those of you who are hunters. If you sit for a long time really quietly in one spot, the animals around you will mostly forget who you're there. What you're doing is you're melting into the acoustic network of the forest. The other animals are listening to what's going on. If a sharp-shinned hawk comes across here, the chickadees will get an alarm call, and the chickadees 200 meters away will know what's happening and transmit it. So there's a news network, an acoustic news network, that is always on and that we seldom get to see in its undisturbed state. We're wandering through the woods. Our nature as primates is to be noisy, garrulous, little social creatures. We're wandering through the woods talking loudly and stomping and picking up twigs and all sorts of things. Other primate species do exactly the same thing. Other creatures interpret that as here comes a predator or a potential predator, send out the alarm. Now, sitting quietly, you can break into that acoustic network and observe its actions. So I sit quietly, the deer walks up to me, doesn't realize I'm there until she's right in front of me, gives an alarm call and runs away. You know what this is, giving that snort. Because it had been quiet, I could then see how all the other creatures reacted to that. And the way they reacted was by giving more alarm calls. And the wave of alarm calls among the chipmunks and the wood thrushes and the tree squirrels spread out from that point where that rock had been thrown into the lake. Spread out. It took an hour for that wave to finally die down, especially the chipmunks. These woodland chipmunks they're not campground chipmunks. They're not used to humans being around. So from then on, I could tell when people were coming through the woods. There's a hiking trail further down the mountainside. 2 or 3 minutes before they arrived, a bow wave of chipmunk alarm calls arrives. And then it's like, there's something going on down there. I bet you it's people. And sure enough, here they come. Now, I am no master at plugging into these things the way that other creatures are, and the way that people who have devoted their lives to really tuning in. There's a book by John Young called What the Robin Knows. I'm halfway through this book, and he's got some interesting ideas about how to tune in to just common birds, juncos and robins, and see what they're telling you about the surrounding landscape. So that network, of course, is just a small part of the enormous network that is connecting creatures in the forest. And this is the revolution that is taking over multiple levels of biology now. And that is the sense that the self doesn't exist anymore. We have this notion of self that has ruled biology now for a long time. I'm not a self, I'm a community of sort of microbiome with lots of different, mostly bacteria and fungi and so forth. And that community affects the health of my gut, affects the quality of my thoughts, the level of depression and anxiety, and so forth. The same is true with plants. They're loaded with endophytes. Any plant leaf is not just a light leaf. Light leaf with a bunch of fungi living within it. Some of those are pathogenic and some are beneficial. And the roots, the mycorrhizae, are exchanging not just material among trees, but also information among trees. The plants are sniffing the air as well, picking up phytochemicals from damaged colleagues so they can prepare the defense before the insects get there. So these networks are popping up all over. And at the molecular level, the way people are modeling the origin of life now is through networks of molecules interacting together. So this is an area where I think where we've got some philosophical challenges sort of beating on the door of biology, and we haven't quite that is, how are we going to talk about things now? When you know that you're a network, you can't be a cell. What becomes of the selfish gene when we know that the interactions among the genes within that genome are so tight that a gene on its own is nothing. You cut the threads of the network and the individual falls out of existence. There are some metaphors we can use here, webs, nets, and so forth. And the key is that we're not talking about love fest, oneness. A lot of these networks are very tense places. In fact, the network is the place where cooperation and conflict get continually negotiated, renegotiated all the time. So we need to get beyond that notion of networking and interconnection into a place where we can understand that none of us is a self. All of us are pluralities. Every system is a network system, and yet there are also differences. It is clear that there is a difference between my body and my technology's body. And yet, at another level, not so much. She goes on antibiotics, I get all those antibiotic resistance bacteria from the dog, even though I don't actually try to kiss them now. Those, the other members of our bodily communities move radically from one place to another. So in writing about a forest, or about any kind of scientific process, particularly about other species, you run into a challenge very quickly. And that is that you cannot transparently represent what you're discussing. You cannot experience it and communicate it without some degree of bias. What do we do about that? And what I've tried to do in this book is actually take the bias itself, take all those difficulties of us imagining life as a fungus, or even be able to understand what is the fungus life history in biology, and actually use those as objects of study in and of themselves. And I'll share a few paragraphs here to try to illustrate that. This is in January, and we had a very cold winter, lots of cold wind moving through, and I tried to lean into the experience and experience the forest as the animals do, deepen my sensory understanding, and see where that would take me. A polar wind rips across the mandala, streaming through my scarf, pushing an ache into my jaw. Not counting the wind chill, it is 20 degrees below freezing. In these southern forests, such cold is unusual. Typical southern winters cycle between thaws and mild freezes, with deep chills arriving for a few days each year. Today's cold will take the mandala's life to its physiological limits. I want to experience the cold as the forest animals do, without the protection of clothes. On a whim, I throw my gloves and hat onto the frozen ground. The scarf follows quickly, strip off my insulated overalls, shirt, t-shirt, trousers. The first 2 seconds of the experiment are surprisingly refreshing. Pleasant coolness after the stuffy clothes. Then the wind blasts away the illusion, and my head is fogged with pain. The heat streaming out of my body scorches my skin. A chorus of Carolina chickens provides the accompaniment to this absurd striptease. The birds dance through the trees like sparks from a fire, careening through twigs. They rest no more than a second on any surface, then shoot away. The contrast on this cold day between the chickpeas' liveliness and my physiological incompetence seems to defy nature's rules. Small animals cool rapidly because they have proportionally much more body surface than volume. The chickadees should perish, and I should live. The wind gusts hard, and the burning sensation in my skin surges. Then a deeper pain starts. something behind my conscious mind is trapped and alarmed. My body is failing after just a minute in this winter chill. Yet I weigh 10,000 times more than a chicken. Surely these birds should be extinguished in seconds. So, first move, astonishment. I can't make it more than 2 minutes in these woods. These chickadees, and this is Tennessee, I mean, this is my actual, like, really cold. We got Quebec. We got chickadees way up there in the Yukon that make even Quebec look pretty warm and fun. They live, well, about half of them survive through every winter, if you notice, perish. And so this is an entryway to talk about bird physiology, their insulation, their amazing vision. How do they manage to see these food inside this forest where I see nothing? It's like, there's food here? No, there's nothing to eat here. And because of the visual acuity and the amazing number of receptors on their retina, they can see, when I see a twig, they see this amazing contortion with all kinds of flakes and details. It's like us looking with our hand legs, spider eggs, little dormant pupae, all kinds of food in there to help them make it through the winter. But I'm learning something beyond that, and the conclusion here is that I cannot fully experience the forest as I wanted to with the chickadees, because my evolutionary trajectory, that of my ancestors and all of our ancestors, has taken us on a different path. It puts a barrier across which we cannot cross. We cannot have an embodied experience of what it is to be one of these birds, and that is a limit to our imaginative capacity. My own physiological inadequacy in the cold has its origins in natural selection. I'm now to place in the icy mandala because of my ancestors. They dodged selection for cold hardiness. Humans evolved from apes that lived for tens of millions of years in tropical Africa. Keeping cool was a much bigger challenge than keeping warm, so we have few bodily defenses against extreme cold. When my ancestors left Africa for northern Europe, they brought with them fire and clothes, carrying the tropics to the temperate and polar regions. This cleverness produced less suffering and fewer deaths, unquestionably good outcomes. But comfort sidestepped natural selection. We are condemned by our skill with fire and cloth to be forever out of place in the winter world. Darkness comes, and I retreat towards my inheritance, the warm hearth, leaving the mandala to the alien masters of the cold. This mastery was earned the hard way, through thousands of generations of struggle. I wanted to experience the cold as the mandala's animals do, but I now realize this was impossible. My experiences come through a body that has taken a different path from that of the chickadees, precluding any fully shared experience. Despite this, my nakedness in the cold wind has deepened my admiration for these others. Astonishment is the only proper response. So the idea here is to hold up that bias, that barrier, and examine it on its own right. One other place where this happens at a psychological level is some little baby raccoons come up to me when I'm sitting on the point and sniff at me. And my reaction is, I want to pick these little guys up. Humiliation. Zoologist, you should not be having those thoughts. This is a common animal. You know, even the word cute, that's for amateurs, that's for kids. Whew, you just crossed the line. Well, that thought came out of a place that I had no place in generating. Just bam, it's there. Well, what's the mirror there? It's into my own naturism, base reading out. Within a fraction of a second, when we meet another human being, we have made a judgment about their honesty, their reliability, how tough they are, all these other characteristics. And then our conscious mind kicks in and puts in the words to explain it. But boy, it happens literally within a fraction of a second. And the psychologists have studied this over and over. The same is true with animals. We're judging them, perhaps misinterpreting them by applying human rules to animal faces. But we have a long agrarian history. We have a long history as hunters, going back tens of millions of years. There's also an instantaneous ability to judge the musculature on the jaws. You know, cute usually doesn't involve huge, great big jaws and small eyes. Whereas big, round eyes and sort of cute little fat thing, well, that is going to be good eating. So these reactions that we have, you know, of course, the TV, wildlife people are very good at exploiting these, either fear reaction or cuteness reaction, as are the people involved in the wild animal trade, that's driving a number of animals into some conservation farms. All very good at exploiting this. What's more interesting is, what does this tell us about who we are and our history? If you're interested in that, I have some Darwin and some Conrad Lorenz, two very important figures in the history of biology, of course, what they thought about animal faces and human faces. Let me close here with a few general reflections. One is about the natural history and why it matters, and what I fundamentally got from this as a teacher and as a sort of ecological professional. My own training involved almost no natural history. So let's learn the big universal ideas that when you leave this place, you can take those ideas, put them in a U-Haul, and get a job, a postdoc, somewhere else. We've unrooted knowledge because academic culture is so mobile. The questions you ask have to be movable. They cannot be rooted in place. And people who study, you know, the local history of this or the local adaptation, that's not real science. Okay, well, that's second rate, and that's very clearly established hierarchy within science. And I think we gain something from that. Universals are powerful, important, but if we lose particularities, we've lost the origin of a lot of this information. Charles Darwin came up with some remarkable universals. And yet, what did he do? He went around his sand walk many times a day. He partnered with particular orchids in his greenhouse. He understood the ecology of his environment, rooted in particular examples from his time, most of the animals and the plants. And now, as a nation, we're going through redoing the science standards for students in schools. All of that is unrooted knowledge. To my knowledge, and I was looking through these the other day, I could find no place where it said, know how to identify the 5 most common trees in your region, 5 bird sounds, and what are the 4 insects you're most likely to. I mean, there's like 20 questions, and yet that would open up huge vistas and worlds of students in their home place. And of course, we have to devise a multiple choice test that was applicable to downtown Phoenix, as well as Brooklyn, as well as upstate New York. But we can do that now. It's not that hard to come up with these tests. We've got the technology and the Flickr photos online and so on to be able to do some of this. And I think that's the generality and the particularity are not in conflict. They feed each other. It's not one or the other. It's one makes the other bigger and richer. And I think that's a big challenge that we face now. So I hope in a small way that singing the songs from this 1 square meter will give a particular example of where that will take us. I also think that the study of natural history can help root some of our political debates in reality. We are engaged as a country in a discussion about human sexuality. And before the Supreme Court, people have talked about biology. If you read about the application to real gay marriage, we want a marriage rooted in nature. Well, have you been out in nature? Oh, those trees are paradise. And also, now biology cannot tell us what is right or wrong. We have to decide what is an appropriate way of engaging in sexuality. There's a lot of cannibalism and forced populations and things that we would not want to be as legitimate ways of being as a human. What biology can do, though, is falsify the arguments and say, this is unnatural. And that's an argument that, to this day, and in fact, in the written documents of the Supreme Court, an argument that's being used. But I think a complete ignorance of natural history allows that argument to be made. These days, we need to challenge that and back off, and not make the argument that, well, we've got to arrange marriage like the chickadees, or like the fungi that have hundreds of different sexes. It's very complicated. That's not the point here. The point here is, though, that there are some bad arguments, and in fact, bad arguments from both sides being made, and we need to move a little bit beyond that. So there are practical reasons why natural history matters. I'll add one more practical reason. Take a big topic, say climate change. Well, how much carbon is being sucked into the forest? That's a question that is being addressed right here. Well, that depends in part on the most obscure thing you can imagine, the growth of twigs. How much twig gets grown every year? That's the ledger. Huge. It's reading twigs, reading growth rate of twigs, how roots and carbons and soil. Things that, if we focus way out on the big picture and have nothing in the educational system that helps people attend to those particularities, we're going to be missing even some important parts of the big pictures. And I'll close by making an aesthetic argument as well. For me, this is where it really is so important. Darwin, all the people after Darwin, the ecologists, biologists, physicists, chemists have shown us so much deeper into the nature of the world. And if we don't tell those stories, if we don't hold them within our minds and within our bodies and hearts, our experience of the world is a shriveled world experience compared to what it could be. A big, fat, juicy experience walking into the woods and of knowing these creatures that are our kin. And that's what Darwin is telling us, that the tree outside the front here is literally my cousin, your cousin. You go back 2-3 billion years to get to the cell that divided and produced the daughter cell that gave rise to you, and the daughter cell that gave rise to that tree. But it's a physical connection of blood line and time together. So for me, the study of natural history, of writing books and teaching is like Thanksgiving dinner. You just get to know the family a little bit. Some of them will drive you crazy. And in biology, some of them will try and kill you, half of all species of animals and parasites. But there's inherent value in knowing that family. You cannot know who you are without knowing some of those kinship relationships. For me, that's an important aesthetic root and ground from which to decide who am I and what is the appropriate way to work and to live in this world. So I think I will close there, and thank you for your attention. I'd be delighted to take questions or challenges and refutations. They are welcome to. They are.
Let's have a few questions, and then we'll let you sign some things out front.
Yes.
I'd like to know what you would think of those creatures in the forest that are not only unseen, but especially capable of camouflaging themselves. So we assume they are absent, and therefore, when environmental policy is enacted, little or no protection is accorded to them. I'm thinking, for example, of the rattlesnake that was right under your feet. And sometimes in New York State, the DEC said, well, we don't see any rattlesnakes in this acreage, and therefore they don't exist. But whose evidence are they really looking for?
Yeah. So the question is about unseen creatures in the forest, and particularly how they might affect policy. I would say also just how they affect just our understanding of what's happening there. That is the big problem. And I would say it's about rattlesnakes critically, but more so it's about the microbial world that is, we can get a little bit out of it by putting it through the DNA blender and figuring out DNA diversity, and through the senses, smelling the soil. Smell of healthy soil is the smell of actinomyces that are, I think, part of the human ecological niche. At least that seems to be how we react as animals. Yeah, there's an enormous challenge of not knowing who is present, let alone what their stories are. And the challenge for us now is there are 7 billion people with growing appetites. Whether or not we want to, we have to manage the world. And yet, we don't even know who's in it. So we're going to be putting on Midsummer Night's Dream here, and we've never heard of Puck or Oberon. Shakespeare, sort of heard of him. And so we don't know the players, the characters, the names, let alone all the subtleties of the plot. And so the question is, how do we act in the face of incomplete knowledge? And not just incomplete knowledge, knowledge that we don't even know exists as potential knowledge. That's the very important way. And there are lots of different answers to that question. For me, it's the appropriate level of caution has to come from actual relationship with the place that is in question. So if we're talking about conservation, say New York forest, well, one way of doing that is you assemble a think tank of people who have had almost no time in the forest of New York, and then make the decisions about these things. And that's how things work where I am. I had a lot of forest policy. In fact, I was involved with Forest Service about a lot of forest management decisions. And it bothered me that we, myself included, we're talking about places that we have almost never visited and we have no personal relationship with. And that, I think, is a poor foundation for policy and ethics. It's like making end-of-life decisions in a hospital. The ethicist there has not sat at the bedside and talked to family members and doctors. They can have all kinds of fancy philosophical ideas about the right ethic for the end of life. But if it's not grounded in experience of working through these and being with people in these situations, you're going to have poor decisions. And I think the same is true in ecology. Out of relationship comes better ideas. And that's tough because that takes some time. But it also embodies within it a certain amount of humility that we don't know it all. Better be listening to try to make the right decision. And there are people right here at various who would be much better honest than I can do that. Because those are,
How do forest wildfires make you feel?
Okay, how do forest wildfires make me feel? It depends where I'm located. So it is clear that, say, just in the United States, there are forests that are adapted to fire if I need it, that cones don't open without fire burning them up. That's a pretty strong signal that fire is part of that system. The forest I looked at on the north-facing mountain slope in Tennessee is one of the least fire-prone forest types in North America. The estimates are that every few hundred years a fire will come through there. On the top of the plateau, so just up from where I am, maybe 20 minutes walk, are these dry sandstone ridges where fire probably came through every few decades, not more frequently. And further south of Florida, of course, there are systems that burn every year or two. So I think we've seen an awakening in North America and beyond about the need for responsible science-based fire management. The problem is the scale of the, say in the West, with the rim fire that's burning out. The scale of these fires and the, say if you want to remove some thin out forest to produce fuel wood, and there's no market for any of the thinnings that are coming out of, say, New Mexico forest, you can't pay for it. And when that fire comes through, it's going to be so intense that it will destroy any hope of regeneration, at least in the short term. So we've got an enormous problem of scale and of the backed up consequences of a series of land management decisions that go back a couple hundred years that are now all over the news. So fire, the role of fire really depends on which forest. erect. And then what we should do about it is an enormous challenge. Some places it's pretty easy to figure it out. You know, we can control burns around longleaf pine forests in the south, and that will help maintain longleaf pine. In the west, when you don't have a good market for some of the timber products that could be used to pay for some of this action, and where a lot of the areas are very, very inaccessible, it's hard to see how we're not going to have enormous fires continuing in the present climate regime, let alone when it gets a little warmer down the line.
David, let's have some time for you to sign some books. I think you've given us some, based on your experience looking at that square meter, some deep insight into the forest, deep insight into how we should think about nature, and interesting questions for all of us to toss over in terms of how we interact with society in a changing world. So many thanks for being with us tonight, and we'll let you escape up the stairs there and sit down at a table and enjoy some conversation and book signing with the audience. Thanks again.
Thank you very much.